So, in the last few sections, we learned about central and inscribed angles. What do we know about central angles? Where are they located?
In the center.
What part of them is on the center? The vertex is on the center. Whereas for inscribed, where are inscribed angles?
On the circle.
On the circle. So the vertex would be on the circle. What do we know about the measure of central angles? The angle in comparison to its arc.
The arc is 2 times the angle.
Central? So which of these is central? The first picture or the second picture? First picture is central. So I'm asking, what is the measure of the angle in comparison to its arc?
No.
It is equal to the arc. So whatever this angle is, the arc will be as well. Whereas you're thinking inscribed, what is the relationship between the angle and the arc? The angle is half the arc, and the arc is double the angle. So the first one we said was a central angle. It is central. So we need to find this arc, and then we would very much know what the angle is. So something to point out would be this line. What do we call a line that goes through the center? Like this. Diameter. What does diameter do to a circle? Cuts it in half. So how many degrees is this portion of the circle? 180. How much of the 180 do we already know? We know 45. So what do I do with this 45 to find what remains? Subtract from 180. So 180 minus 45 means that this arc is 135. So then what's the measure of A if the arc is 135? 135 also. Because central angles are congruent to their arcs. Whereas the second picture, it is inscribed because C is the vertex and is on the circle. So we're finding an angle. So use the arc to find the angle. What do I have to do to the arc to find x? Divide by 2, which is 62 degrees. The angle is half of the arc, and the arc is double the angle when it is inscribed. You're going to draw another 2 pictures. Going to draw these 2. So in this first picture, we're finding x, which is an angle. What kind of angle is it? Central angle. So here's its arc. It's AC, and it's 35 degrees. So then what's the measure of x? 35. So central are going to be congruent to the arc. This next one looks like a lot of things are happening. But let's start with the 32 degrees, because that's a number we know. What kind of angle is 32 degrees?
Inscribed.
It's inscribed. So we can use this to find some other information. If it is inscribed, AB is its intercepted arc. What is the measure of AB going to be? 64. How did you find 64? It's double of that. So we know the arc is 64. We want to find x. What kind of angle is x? It is central. And what do we know about central angles? They're congruent to their arc. So then what's the measure of x going to be? 64. So sometimes you have to use something, find something else before you find your answer. I believe we have 3 more pictures. Yes, these 2 and then 1 more. Go ahead and draw these 2. All right, so we're going to find x in the first picture. We got to use what we know. We know angle K is 25 degrees. What is the name of its intercepted arc? HI. So if the angle is 25, what is the measure of its arc? 50. This is inscribed. It's on the circle. We're trying to find x. What is the name of its intercepted arc? HI also. What kind of angle is x? Inscribed also. So then what's x going to be? 25. They both intercept the same arc, HI, so they have to be the same measure. The second, Kobe, what kind of angle is 162? Central or inscribed? Where's the vertex? Central. So N is on the center. So then, guys, what's the measure of this arc? 162. And if we want to find x, what kind of angle is x? Inscribed. Its arc is the same as 162. So then, is x 162? It is not. What is it? 81. It's half of 162. Perfect. From this section, you also learned about circles. Not circles. You learned about triangles. Let's say you had a triangle where one of the sides was the diameter. Does anybody remember what kind of triangle it will be if it'll be a right triangle? Because what would we call the side that is the diameter? The hypotenuse, which would mean across from it is a right angle. So you will have one of those on the quiz. You'll also have a quadrilateral. I'm going to draw something with 4 sides. Yep, close enough. What do we know about the opposite angles in a inscribed quadrilateral? They're supplementary, so they would add up to 180. So keep that in mind. If this was 100, this one would have to be 80. So that's what we learned from 1.4. We're not going to draw that one. But the last thing we're going to draw from 10.1, go ahead and draw this picture. Determine if line AB is tangent to the circle. So if it is tangent, what will a tangent line be? It'll have a relationship with a radius. What will the tangent and the radius be? They'll be perpendicular. So in order for it to be tangent, the tangent line and the radius will be perpendicular. So we're trying to see if AB is a tangent line. So where would the right angle be? At A, B, or C? At A. We want to see if there's a right angle at A. If there is a right angle there, then we have a tangent line. If it's not there, then we do not have a tangent line. How do we figure out if we have a right angle there? Pythagorean Theorem. Do we know all three side lengths at the moment? No, but we can. Don't call this R. It is the radius, but the radius goes from the center to the edge, right? And in a circle, the radius should be the same. So what is the radius of this circle? It's 12, just like on this side. So what are my A and B going to be? 16 and 12. And then C, it's going to be what? 20, because 8 plus 12 is 20. So now we want to see if the left equals the right. If it does, then yes, it's tangent. If it does not, then it is not tangent. 16 squared is 256. What is 12 squared? 144. And then 20 squared, 400. What is 256 plus 144? 400. So is this line tangent? Yes. So your answer is yes. Your quiz will say to explain. If it says to explain, you would say because the tangent and the radius are perpendicular, or because the tangent and the radius form 90, something to that effect. So at this point, we're ready to play our game. Go ahead and take out a whiteboard marker and an eraser. All right, so we're going to start with this question. You're going to find the measure of each of those arcs for A, B, and C. Find arc SW, QUW, and UW. You show me your answer. There'll be a first place, second place, and third place. If you need to stand, you're welcome to stand. Check the second one.
Which one?
The second one. First. I would say it helps if you draw the picture. Not quite. You only use 180 if there's a diameter. A diameter goes straight through the circle. Your second. Check your second one.
If you agree.
The second one is wrong. All right, let's answer it. It says QNS is 80, so that means its arc is 80, because these are central. SNU is 65, which means this is 65. QNW is 95, which means this arc is 95. So find arc SW. It has to be less than 180. So if you went the other direction, you would have something bigger than 180. But what is 80 plus 95? 175. So that's minor. That's good. How did I know SW would be minor? It's 2 letters. QUW, so Q through U and a W. It is all of the circle except for how much?
QW.
Except for QW. How many degrees is QW? So it's all except for that 95. So you can subtract that from 360. You get 265. And then last, it says UW, which again will be minor. That is, it would be 120. You would add these 3 and subtract them from 360. All right, so you're going to find the question mark. There are 2 ways to find this. First, second. That's not the question mark. You found something important, though. Third. That's good. There are 2 ways to find this. Option 1, what kind of angle is 55? Inscribed. So then what's the measure of XY? Double that. So it'll be 110. This is the diameter, isn't it? So how many degrees is this whole part of the circle? 180. So subtract 110. That means the question mark is 70. That's option 1. Option 2, the question mark deals with this angle. What kind of triangle is this? It's a right triangle. One of the sides is a diameter. That's going to be a hypotenuse. This angle will be a right angle. This angle would be 35. Double that, and you still get 70. So both are correct. All right, in the diagram, CD is 26. DF is 168. CF is 172. Is DF tangent to circle C? And explain your reasoning. We did one like this on our review today. You want to show me the work, you know. You got to explain your reasoning. Your numbers are wrong. Did you double them? You're not supposed to double them. Good job, you're first. Good, you're second. And then you're third. Good. So what do we use to figure out if this is if this is a tangent line? The Pythagorean Theorem. So that's what you should be squaring. So you do a squared plus b squared equals c squared. 26 squared plus 168 squared equals 172. Is not because a tangent line is not perpendicular to the radius. These are the two numbers you should get when you use the Pythagorean Theorem. All right, you're going to name the circle. You're going to name a diameter and name a secant. You do need to name them correctly. So you're going to name the circle, name a diameter, and you're going to name a secant. So you got to name them correctly. Remember which ones are segments and which ones are lines. You want to name them that way. This is from 10.1. Not quite. Wow. That's 3 letters. It's interesting.
Oh.
Intriguing. I would take out 10.1. This is not looking well. Not quite. Gotta name lines like lines and segments like segments. Close. One of them's right, one is wrong. No, I was looking at his, Connor. I was just reading yours. Yep, you're first. The first way wasn't wrong, that part. Your third one's wrong. Your third one's wrong. Alright, let's talk about it. How do we name a circle? There's 2 ways.
Circle and you name the point in the middle.
Yeah, you circle and then the center, or you can draw a circle in the center. I don't have a circle button, so that's the best I got. A diameter, is it a line or a segment? It's a segment, so you should name it like one. It goes through the center. So this is the diameter. So what 2 letters should I be using? KN. You could also say NK. Those are the only 2 options. Because is Q in the or on the circle?
No.
It is not. Neither is S. And then a secant is a line. So you should be naming it like this. It hits the circle how many times? Twice. But it keeps on going. So the secant is here. There are a bunch of answers. You could say SK, SP, SN, SQ. You could say KP, KN, KQ. Oops, sorry. There are a bunch of answers for that one. Find the value of x. Also from 10.1. Trey, are you discouraged because I won't let you bring cups? Plates. That's why. Interesting. My daughter looks like that too when she's told no. This is from 10.1. It's like page 3. This though, so you see how you screwed this in? Just because you're using the Pythagorean theorem. Sounds good. So it wouldn't be 9 times x, it would be 9 plus x. Good. All right, so you should have set it up using the Pythagorean theorem. A squared plus b squared equals c squared. Which of these is a and b? 15 and x. 15 squared is 225 plus x squared. And then c, I know they're really nice and they gave you a right angle. Just make sure you're able to know where the right angle is. It's between the tangent and the radius. But what is the full length of that hypotenuse? 9 plus x, or x plus 9, you're going to get the same thing. Then you're going to square it. When you're squaring something, you're multiplying it times itself. So you should distribute the 9 in. You get 81 plus 9x. And then distribute the x in. X times 9 is 9x. What is x times x? X squared. What happens to the x squareds if I try to move either of them? They cancel. Because if you go to subtract, that one's gone. I subtract on that side, that one's gone. So you have 225 equals 81 plus 18x. Subtract the 81. What is 225 minus 81? 144 equals 18x. Divide by 18, and x is 8. So you're going to find the value of y and z. This is from 10.4. I think you're correct. Can you face it more from me? You would just need a math on angle G better. So angle D is y, angle G is z, angle F is 74, and then 102. So what do we know about opposite angles? They're supplementary. So z should be 78, and that means y will be 106. Find the measure of each arc.
Everybody else is already done.
Oh, person, sorry.
What did you do? I was going to do it.
Second.
I took three. So you might as well not do it anymore.
You're correct, but he's a little before you. So, what's helpful? First of all, are these central or inscribed? Central, so they're congruent to their arcs. This is 50. What do we call this line that goes straight through the center? Diameter. So we know how many degrees are over here? 180. We know these are 180. So that means this should be 130, which this is 130, this is 50. And then just go from there, finding PR is 130, then 180, then 230, then 130. You're going to find the value of x.
I ain't got no.
That's a problem, man. Is there a number behind that first one?
No.
Okay, you first.
Yeah, I got the right side, I can calculate.
Yeah, I think that needs to be confiscated.
Second.
That's outrageous.
Good. All right, what kind of triangle is this?
Right.
It's a right triangle, because this is a diameter, which means it's the hypotenuse. This is a right angle, so 2 on E3, x minus 2 equals 90. Add 2 divided by 23, and you get 4.
I did get this one right.
There is one like this on the quiz. Find the measure of angle T, and you're going to find the measure of arc QR.
This is outrageous.
That 30-second mark, everybody else is already covered.
Is it not?
Oh, God's sake. My bad.
30.
Game.
All right, so I feel like everyone got T. What do I do to find T?
You divide 4 by
You divide by 2, so you get 22. QR is different. QR does not have an angle it's attached to, right? So you need to find something else before you find that. TQ you could find because you know 47. What do I do with 47 to find the measure of arc TQ? Multiply by 2, and you get 94, right? What do we call TR, this line in the middle? It's a diameter. So how many degrees is it from R to T? 180. You know 94 of it, which means QR has to be 86. You will see a question like this on the quiz. Very similar, different numbers. It is the new quarter, yes.